So to continue our introduction of monopsony, I want to just clarify and kind of re-go through a lot of things that I did in Excel in the last video and kind of just slow it down a little bit more, make them a little bit clearer, and kind of hit some main points that I think confuse a lot of people. So the first thing is that I didn't label this graph in Excel, and I should have, frankly. But this graph right here, this is the labor market. So this is the market that the firm enters to basically to hire workers. So this is not the output market. This is not the market for the product that the firm is selling. So let's say that this firm is selling shoes. So we are talking about a shoe company. So if this company, if we were to draw the market for shoes, we have shoes. This would be the entire market, the market for shoes. We would have price here and we would have quantity here, and we would have our downward sloping demand line and our upward sloping supply line, and we would get a price of $5. And this would be the market price. And that's where we get this from. And that's why I put perfect competition up here, because while this firm is a monopsony for the inputs, it has to sell its product on the global shoe market. So you could imagine this company being like the only shoe factory in somewhere in Southeast Asia. So they're the only factory that's in town. So they have power in the labor market. They have the ability to impact the labor market there. But they don't have any power in the world market for shoes, because they have to compete with companies from all over the rest of the world. Okay, so that's the first thing. Now if I were to draw the, so let's draw the firm's cost curves. So the firm's cost curves, this is going to look exactly like, this will be like perfect competition in the short run. So we will have their price line right here, and then we will have a upward sloping marginal cost curve, and marginal cost will intercept average total cost at its minimum. And so this would be average total cost, and then we see that they're making a profit. So because they're making a profit, we know that this has to only be in the short run, because we saw that they were in a perfectly competitive market for shoes because the price was constant. So this would only be in the short run. In the long run, we would expect that the price would either rise to average total cost, or that average total cost would drop down. And so average total cost dropping down, we get that this firm would earn zero economic profit in the long run. Alright, so that's all that I want to say about that stuff over there. So now we're going to kind of go through these calculations one more time, and what I'm going to do is I'm going to highlight a box that we're talking about the calculation for. So I'll put, a little red squiggle in this box here, and then down here in the bottom left corner we'll kind of walk through that calculation. Alright, so how we get the marginal product of labor, this should be review at this point, and I'm only going to do one of them. And you know what, I'll do the second one because it's a little bit more interesting than the first. This is the increase in output that can be associated with a 1 unit increase in labor. So we have the change in output, which is going to be 30 minus 10. This is the change in output over the change in our input, which is labor. So we have 2 minus 1, and that is the change in our input. So you just do the subtraction and the division, and we are going to get 20 over 1, which is equal to 20, which is exactly what we see in this box right here. So that's all that I'm going to do with marginal product of labor. I think we've covered that a bunch now, and we're going to go on to some other ones. So I'll just kind of erase those, and we'll get over to, let's see, we're going to jump to marginal revenue product of labor. So really quickly, we know price I gave you. Total revenue is just price times quantity. So this is equal to P times Q. So our price was $5 and our output, our quantity was 10 shoes, excuse me. And 5 times 10 is 50. Okay. Now the marginal revenue product of labor, and this should be review also. The marginal revenue product, and I'll put down here, of labor. And this is normally how it's written. Your class may do it a little bit differently, but this is kind of the standard. The marginal revenue product of labor is just going to equal, there's a lot of ways to do it, but one way to do it is the marginal revenue times the marginal product of labor. And so doing this out, we are, sorry, I already kind of violated the formula I was saying I was going to do. I was going to put a little squiggle for what box we're calculating. So this marginal revenue product of labor is going to be the product, the multiplication of 5 times the marginal product of labor, which is 10. So in this case, this is equal to 5 times 10, which is 50. Now let's go calculate one more cell of that. So we're going to go calculate this cell. And so we are going to see that this is $5 times 30. So we have, in the green one, this is 5 times 30, which is equal to 150. Now I said there are a lot of ways to calculate the marginal revenue product of labor, and I don't know that there really are a lot, but I can think of at least one more, which is why I said it. So I'm going to go show you the other way that this makes sense in my head. If this confuses you, just ignore it. But for me, it makes a lot of sense, and it kind of builds some more intuition for how we calculate the marginal product, revenue product of labor. Again, it builds some intuition for how we calculate the marginal revenue product of labor. So this is the marginal revenue product of labor is, by definition, it's the increase in revenue. So this is the increase in total revenue with, or for, I guess is a better word, for a 1 unit increase in labor. So we know that we are only increasing labor by 1 right here. We're going from 3 to 4, which is an increase of 1. So we can just look at the marginal revenue product of labor here as the change in total revenue. And I'll say that one more time. So because we know over here that we are increasing labor by 1 unit every single time that we jump, we can say that the marginal revenue product of labor is just the change in total revenue. And the change in total revenue is going to be 425 minus 300, which is 125, which is exactly what we have here. Alright, so what would we do if this went not from 3 to 4, but from 3 to 5? So we'll do this in orange. Well, what we would do is, there's 2 different ways to look at it. One is that this plus 125 is now we are getting that increase for 2 workers, so we should just cut it in half. And that's actually a valid way to look at it. So if our change in total revenue then would be 425 minus 300, still exactly the same, right here. But our change in the number of workers would be 5 minus 3, which would be 2. So we get 125 over 2. And I'm not going to calculate that exactly, but it would be somewhere in between 50 and 75. It'd actually be 62.5, I think. But that's beside the point. So this would be one way to look at it. Another way to look at it would just be that the marginal product of labor here would also be half of what we calculated it to be, and then we could just multiply these. So the marginal revenue product of labor would be 12.5 because we got 85 more, we got 25 more units of output for 2 more workers. So for each individual worker, we are getting, on average, 12.5 more units of output. And so then we could just multiply that 12.5 by 5, and that would also get us that 62.5. So I hope that was helpful. If it was confusing, just kind of ignore the second route, and you should be fine just with this route right here. But that's all that I want to say about the marginal revenue product of labor. I've kind of shown you all of my tricks for it. So we will now hop into the other stuff. So the total labor cost, I just included this because I think it makes the explanation clearer. This is just equal to the wage rate. So this guy right here, we'll do a star, is just equal to the wage rate times the number of workers. So it's just 4 workers at $50 a person gives us $200, and we could say this was per day or per hour or whatever you want to say. So then the marginal factor cost of labor, and I'll change colors one more time. So let's talk about this one right here. The marginal factor cost of labor, this is the change in total cost. So I'll write this out. This is the change in total cost. So I'll use a delta, a triangle, for the change. The change in total cost for a 1 unit increase in labor. So I didn't include any other costs for this monopsony just to keep it really simple. So we're assuming that labor cost is the only cost, which is obviously an unrealistic assumption, but it makes the analysis simpler here, so we're just going to start with that. So all that we are calculating over here is we are calculating the change in labor cost. So we know that our number of workers is increasing by 1. And so all that we are going to do then is we are going to have, sorry about that, we are going to have 120 minus 60. So this is the marginal factor cost of labor is equal to 120 minus 60 over this is the change in total cost, right here, divided by the change in labor, because we want for a 1 unit increase in labor. So we're going to divide by the change in labor. And it turns out we're dividing by 1 because we have only a 1 unit change in labor. So here we have 3 minus 2. So we're dividing by 1, and it really makes no difference. But you can see in my other example where I was saying, what if this was 2 to 4 right here? That's where that would make a difference down here. So I hope that didn't confuse you. If it did, you can just ignore that part too. So then this will just be 60 over 1, which is 60, which is exactly what we have right here. And then lastly, profit is just total revenue minus total cost, which we are assuming is just labor costs. And I just put that there to show you that profit is maximized when marginal factor cost is equal to marginal revenue product of labor. And so one more time, this is kind of the kicker for monopsony. This is the whole reason we look at it, is that if firms have power in the input market, if firms have power in the labor market in this example, firms are going to maximize profit when the marginal revenue product of labor is equal to the marginal factor cost of labor. And the reason that is that if the marginal revenue product of labor is greater than the marginal factor cost of labor, like right here, so I'll write that out, we have the marginal revenue product of labor is greater than the marginal factor cost of labor, then what that's saying is at this amount of output, this number of shoes made, we are getting more, our worker is making us more money than we have to pay him. And I'm going to say that one more time because it's the most important part. At this level of output, this number of workers working in this level of output, you know what, I should label this graph. This is number of workers. So with this many workers hired, and I kind of drew it in the middle, but we could scoot it over a little bit, our workers are making us more money than we have to pay them. So we're obviously going to keep hiring workers. Now on the other side, and I'll switch colors up one more time, if the marginal factor cost of labor, so I'm kind of skipping around, I apologize. So here we are going to hire more. Now on this side, if the marginal factor cost of labor is greater than the marginal revenue product of labor, like at right here, then we are going to hire less workers because they cost us more. The marginal factor cost is higher than what they earn us, their marginal revenue product. So we are going to hire less workers. And again, that's because they earn us less. Their marginal revenue product is less than what we have to pay them. So I did that backwards with the little pointer. The marginal revenue product, what they earn us on the blue line, is less than their marginal factor cost, the increase in costs for that extra worker, the red line. So because they cost us more than they make us, we are going to hire less workers. And we are going to keep on kind of doing this seesaw back and forth until we get to the point where the marginal revenue product is exactly equal to the marginal factor cost. And I'll just draw the seesaw kind of in on this side too. So we're going to keep on kind of hiring more workers or hiring less workers until we approach this point right here. So the very last thing that I want to say is we have to decide what we're going to pay these workers once we've decided how many. Well, we don't get to decide. We have to figure out how much we're going to pay these workers once we've decided how many we're going to hire. And so all you do for that is you know that you want to hire, in this case, 5 workers. So you go down from where marginal revenue product is equal to marginal factor cost. You go down to the supply line and then over to the wage or the price, and you find that you're going to pay them $60. Now in this table over here, you could see that we're going to pay them $60 by finding this point right here, where marginal factor cost is equal to marginal revenue product, and then going over to wage. And you'll see that that's $60 also. So that's really all that I want to say about monopsony in a broad sense. We'll work some more examples for sure, but at this point you should have a good idea of that monopsony is dealing with inputs, not outputs, and that monopsony in the input market is very similar to monopoly in the output market. And you should understand the profit maximization condition that marginal revenue product is equal to marginal factor cost. And then you should kind of be able to work through all of the columns in this table. And you should also be able to find where the equilibrium is and then find what the wage rate will be. So if you can do all that, you should be pretty good to go.